We saw in the last segment that Earth's orbit is very close to being a circle, but it's not a circle, it's an ellipse. The sun is slightly offset from the center. This is typical of a planetary orbit. The planets have they have elliptical orbits, but they're very close to being circles. The sun is just a little bit offset from the center. In fact, an ellipse has two, instead of having one midpoint like a circle, an ellipse has 2 points called foci. The sun is at one of the foci of the ellipse. There are other bodies that orbit the sun, like comets. Comets orbit in much more elongated shapes. They are more eccentric. They have really long, skinny orbits. Now, if you look at the same images we see on the screen, if you look on page 123 in your textbook, you see that these images are put in order from roundest to most elongated. And if you look carefully, you'll see that the sun is going from the roundest orbit, and you can see that on this image too. You can see that in the roundest orbit, the sun is very close to the center. And in the most elongated orbit, the longest and skinniest orbit, the sun is closer to the edge. And if we put them in order, we can see that the sun gradually moves from near the center to near the edge. So we can recognize a pattern that the farther the sun is from the center of the ellipse, the more elongated, the more long and skinny that orbit is going to be. How can you describe the shape of an orbit? How could you, without drawing an actual ellipse, how could you describe precisely the shape of an ellipse to another person using numbers or words? Well, with a circle, it's really easy, right? Because a circle has one midpoint and one radius, and all the points are one radius away from the midpoint. With an ellipse, it's not quite so simple. With an ellipse, you have to define it relative to the locations of those two foci, those 2 points. The sun is at one of the foci. The other focus is on the other side. It's on the other side of the center of the orbit, an equal distance away from the center. So if we look at this image, we can see some ways that some measurements you can use to define the shape of an orbit. If we look at the distance, the longest distance from one side of the orbit to the other, and then cut that in half, that's called the semi-major axis. We can see that that's represented by the letter A. You could call the whole distance across the major axis, and so half the distance across is the semi-major axis. If we look at the shortest distance across the ellipse that crosses the midpoint, then that is the minor axis, and half of that is called the semi-minor axis. So the semi-major axis is represented by the letter A. The semi-minor axis is represented by the letter B. Notice that since the sun is not in the center, sometimes the planet or the comet or the other orbiting body is sometimes it's closer to the sun, sometimes it's farther from the sun. The point at which it is closest to the sun is called perihelion, and the point at which it is farthest from the sun is called aphelion. These are important vocabulary terms that we're going to be using. The shape of an orbit or of an ellipse, the shape of an ellipse can be described by a value called its eccentricity. The eccentricity describes how much the orbit is elongated, how flattened out it is, how different it is from a circle. So a circle would have an eccentricity of 0. And the more elongated, the farther that the foci get from the center point, the greater the eccentricity is. Eccentricity is calculated as the distance between the center and the focus divided by the length of the semi-major axis. So if the the uh, the distance between the center of the focus, when it gets very close to the length of the semi-major axis, then the eccentricity gets very close to 1. So a very flat, long, skinny ellipse is going to have an eccentricity very close to 1. So eccentricity ranges from 0, which is a perfect circle, to 1, which is completely stretched out and flattened.